Today we're going to talk about half-life. Half-life is the amount of time it takes for half of a radioactive material to become non-radioactive. So radioactive material can be very useful, can be very dangerous, but in terms of half-life, it is extremely helpful because it can help scientists figure out how old different substances are. Each radioactive substance does have a half-life and it's specific to that substance. So if a scientist knows the half-life of a specific substance and they know that there's 50% of the radioactive material left in that substance, they know that that thing is only as old as that radioactive material's half-life. And so what we are going to do today is we're going to look at a few different problems and use the knowledge of half-life in order to figure out different aspects of the problem. So let's go ahead and look at this first problem to figure out how we're going to do this. So the first one says, after 16 days, 8 milligrams of an originally 128.0 milligram sample remains. What is the half-life of the sample? So when we're doing these types of problems, there are a few pieces of information that we need to know. The first thing that we need to know is how long this decay is going on for. Okay. The other things that we can know is how much of the sample is left and how much we started with. So I like to pull out the important piece of information. So our starting amount was 128.0 milligrams, and our ending amount was 8 milligrams. And we know that the decay length was 16 days. And what the question is asking for is, what is the half-life? Another thing that you're commonly going to see in these problems is the number of cycles that this went through. When we talk about cycles, we're talking about how many half-lives were able to occur in 16 days. So we are going to do this all with simple math. So if we are given a starting amount and an ending amount, whenever we have masses, we're always going to decay it because that's the thing that's breaking in half. So we're going to start with 128.0 milligrams, and the definition of a half-life is that half has gone away. So after our first cycle, we're going to take 128 and divide by 2, and we get 64 milligrams is left. So that is one cycle. And we want to keep decaying until we get to our ending amount. So our second cycle is going to get us to 32 grams. Our third cycle is going to get us to 16 grams. And then our last cycle is finally going to get us to 8 milligrams. So what information we got out of this is that there were 4 cycles that occurred within this time. Okay, so we know that this decay went on for 16 days, and we want to know what the half-life is. So your half-life is going to be equal to the decay length divided by the number. So x is equal to 16 days broken up over 4 cycles means that each half-life was 4 days. Okay, let's try another one. Okay. So this one says the half-life of zinc 71 is 2.4 minutes. So we know that that's the half-life. If one had 40.0 grams at the beginning, so that's our original amount, so our starting amount, how many grams would be left over? So we are looking for after 7.2 minutes have elapsed. So 7.2 minutes is the length of the decay. Okay, and the last thing that we need to know is the number of cycles. Okay, so since the ending amount is the unknown, we have to start with our time. So they're either going to give you two values of mass, or they're going to give you two values of time, and then it tells you whether you're starting with division or if you're starting with decaying. So this one we're going to start with division. So we know that the half-life is equal to the length of the decay divided by the number of cycles. Okay, so we know that the half-life is 2.4 minutes, and the length of this decay was 7.2 minutes, and we need to figure out how many cycles this went through. So we do that by solving for x. So we can cross multiply here, multiply both sides by x, so we get 2.4 minutes times x is equal to 7.2, and then we get x is equal to 7.2 over 2.4. And so that tells us that our number of cycles was 3. Now, with that information, we know how many times we have to decay down 40 grams. So we start off with 40 grams, and after our first half-life, we end up with 20 grams. Our second half-life, we end up with 10 grams. And after our third half-life, we end up with 5 grams. And that will be your final